Welcome back to part 2 of chemistry. So, you have your pure substances and physical mixtures. So, your pure substances, these have distinct, fixed proportions. Okay, they have unique properties. Aluminum foil is an example of a pure substance. It has only atoms of the element aluminum. I about said that word wrong. So, then you have your physical mixtures.
Or if you're English, it's aluminium.
Aluminium. That's how I was trying to say it, like I was English. Okay, I really was. Okay, so your physical mixtures. These are a combination of matter in any proportion. So you can have a little bit, say 1/8 of an ounce of one thing and 2 gallons of another. It's still a physical mixture because you've mixed two things. So the properties of a physical mixture are combined properties of the substances in the mixture. Salt water is a physical mixture of salt and water of any proportion. So now you have your solution.
Okay, so when we talk about mixtures, solutions is one that we use quite a bit in the salon. So it's a blend of 2 or more liquids and or a solid dissolved into a liquid. So when you have a solution, generally you have a solute and a solvent. Water is considered the universal solvent. You can dissolve so many things in water. Salt water is an example of a solution where water is the solvent, salt is the solute. If you think about, if you were like me as a kid, we had a lot of Kool-Aid growing up. So water was the solvent and the Kool-Aid powder was the solute. So generally it is a solid and a liquid, but it can be 2 liquids. But when you make a solution and you mix it up, you can't, it's very difficult. I won't say you can't, but it's very difficult to unmix it. It's going to stay mixed up. If you have salt water, you've made salt water, that salt is going to stay dissolved in that water. In order to separate them, you have to evaporate all the water to get it to go away. So they're going to stay mixed together when you have a solution.
Use your Kool-Aid, for example. Like you could say your Kool-Aid is going to be red Kool-Aid from day 1 to day 100
Yes,
years.
it is. It's not.
It's never going to be red at the bottom and clear at the top.
And clear at the top. It's always going to stay mixed. Not true of all things, though.
So then you have your solutions and your suspensions. So a miscible liquid. These are mutually soluble, meaning that they can be mixed together to form clear solutions. Water and alcohol are example of miscible liquids, as in nail polish remover. So when these substances are mixed together, they will stay mixed, forming a solution. So then you have your immiscible liquids. My glasses are falling off. Okay. So they are not capable of being mixed to form a stable solution. For example, oil and water. So I can shake my oil and water, my oil and vinegar, okay? Oil and water.
Oil and vinegar salad dressing.
Salad dressing.
Yeah.
I can shake it. It's going to be in bubbles. But it still will separate the minute I stick it back on the table at Olive Garden. So, then you have suspensions. These are unstable physical mixtures of undissolved particles in a liquid. So,
your salad dressing
would
be a suspension. All right. And we have emulsions and emulsifiers. These we use quite a bit. An emulsion is an unstable physical mixture of 2 or more immiscible, meaning they cannot mix, substances. So things that would not normally stay blended together would be an emulsion. So when we have these emulsions, we have to have an emulsifier in order to have them. So it's an ingredient that brings 2 normally incompatible things together and allows them to stay blended and be stable. So if you look at certain beauty products, and they have ingredients that say water is an ingredient and maybe oil is another ingredient, but it's a cream. Like I think olive Olay, if you look at their labels, just the regular olive Olay or Pond's Beauty Cream, there is an oil and water mixture that, and it stays together, and that's because of the emulsifier. It's the use of the emulsifier in the emulsion that helps it become a stable mixture that we can use in the salon.
Excuse me.
Go ahead.
That's why it's important to read the directions of your hair products, because some will say shake well. The reason it's telling you to shake well is generally because those chemicals that make that product will tend to separate. So if you don't shake it well, then you're not getting the proper benefits of that product for the hair.
Yeah, if you've got a suspension, something where the ingredients are just floating around each other, if you don't shake it, you're going to get something where just one of the ingredients that sits on top comes out. All right, so when I talk about emulsifiers, you can't not talk about surfactants, okay? So surfactants are what allow us to have emulsions. So they allow oil and water to mix. And when we talk about a surfactant, think of you've got this thing. It's got this end and this end. Just think of an oval shaped thing here. And one side of it loves water, and that's called the hydrophilic end because it loves water, hydro. This end, lipophilic, and lipophilic means it loves oil, but it's two ends of one molecule. So this side loves water, this side loves oil. Together, what they do, especially when we use shampoos, they create this push-pull little thing that goes on, and this side attaches to water, this side attaches to oil, and that's what allows us to get those things to come together.
Yeah.
So when we're using them in shampoo, what happens is the hydro side attaches to the water that's going down the drain, while the lipo side attaches to the oil and dirt in our hair. And since they're together, when that water side gets rinsed down the drain with the water, the oil and dirt go along with it. So you will find surfactants a lot. And when we talk about emulsions, a lot of them are going to be oil and water emulsion, meaning it's mostly water with just a little bit of oil. And some of them are going to be water and oil emulsion, so just a little bit of water with a lot of oil. So it's pretty cool how that works. We also have, and this just gives you a little list about solutions, suspensions, and emulsions. So your solutions means they're mixable or miscible. No surfactants are needed. It does give you a stable mixture. And they're usually clear or semi-clear. Suspensions, they're slightly mixable. No surfactants are there. They're larger particles. But it is an unstable temporary mixture, meaning if you sit it down and let it sit for a long time, it's going to separate. These are the ones you have to shake before you use. If you've ever used calamine lotion, that pink stuff your parents put on you when you get poison ivy or a rash, that's another example of a suspension. You got to shake it really well before you use it. Emulsions, they're not mixable unless you have a surfactant. Yes, larger particles, and they're usually solid in color. Shampoos, conditioners, lotions, creams, things like that would fall into the emulsion category. Okay, so other physical mixtures. We've got solutions, suspensions, emulsions, and
Now we have ointments.
yes.
So your ointments, these are semi-solids. So you think of Neosporin. You think of
Chapstick.
They are made with any combination of petroleum, oil, and wax. That could also be maybe your pomades, styling waxes, that type of thing. Then you have your powders. These are physical mixture of two solids. So these would be off the scalp powder lighteners would be a physical mixture, that type of thing. These mixtures may separate, so sometimes you may have to shake them, stir them, that type of thing.
I knocked that over. Sorry.
That's all right. So,
All right. So when we talk about all these physical mixtures and all these conditions that we can find our products in, there's ingredients that when we talk about chemistry and cosmetology that we need to know. And some of those common ingredients, one of them is volatile alcohols. And a volatile alcohol, think of rubbing alcohol. It evaporates quickly. Ethyl alcohol in hairspray. You've got different types of the alcohol you drink, the alcohol you don't drink. But those are both considered volatile alcohols. Now, why do we consider them volatile? Well, if you put a match to it, what happens? They will burn and they evaporate quickly. So if you leave something sitting out, alcohol is going to evaporate really quickly. The next one we have, and we're going to
listen carefully.
Alkanolamines.
All right, let's do that again.
Alkanolamines.
Alkanolamines.
Alkanolamines. That is always a tongue twister.
Yes.
That's why we let that one do that for
Yeah.
you. And this is a substance that's used to neutralize acids or raise the pH of hair products. One that we commonly use is ammonia.
Yeah.
Okay. And then going on to ammonia.
Ammonia. So it is, we all know what ammonia is. It's colorless and it stinks.
It does.
So,
If you've ever smelled cat pee,
yes.
it
you know
kind
what
of
I mean.
smells like cat pee.
So ammonia in hair products or stuff we would use would raise the pH in a permanent wave, hair coloring,
lightning
lightening.
products.
So it's raising the pH, it softens, it swells the cuticle, that type of thing, and it allows a solution to penetrate that hair shaft. Another substance would be glycerin.
Yeah. And glycerin, you will find glycerin in a lot of products. Glycerin soap, glycerin hand creams. But it is a sweet, colorless, oily kind of substance, and it is used as a solvent and as a moisturizer.
It's in a lot of your hand lotions, which we all need right now
Yes,
because of the hand sanitizers.
because of all of the volatile alcohol hand sanitizers we are using on our hands.
Right.
Silicones is another product that we use a lot, and some people give silicones a bad rap because they want all natural everything. But silicones do have their place.
Yes.
And it is basically a special type of oil that's used in conditioners and in hair products that is water resistant. It helps get rid of the water. So in nail polish dryers, there's a lot of hair oils and skin things, or not skin things, but skin moisturizers that use those silicones. And when you live in the South like we do, in those summer months when it's very humid outside, you want as much humidity resistance in your hair as possible. So if you have a product that coats your hair with silicone, that water or that moisture and the humidity in the air is going to bounce off. It is not going to be able to penetrate your hair as easily. So silicones are a good product, or a good ingredient to have in a lot of your products.
Then you have your VOCs. These contain carbon. That means they're organic.
Yeah.
And they evaporate easily. That means they're volatile. So, but most of your VOCs used in hairsprays is your ethyl alcohol. So,
Okay, so those are common ingredients. When we talk about hair products or skin products, we often talk about pH. And for years, I really didn't understand what pH was. I'd heard of it. I knew there was a pH scale, but I really didn't know what it stood for. And pH just stands for potential hydrogen. And we know hydrogen is an element because we talked about that in the last
yes.
video. So the P represents the quantity, the potential, how much hydrogen is going to be there. And the H represents the hydrogen ion. So an ion is an atom or a molecule that carries an electrical charge. And you will see those ion hair dryers and different things. All it means is that hydrogen molecule carries an electrical charge. Ionization is the separation of a substance into ions, electrically charged molecules. And you have two different types of ions. You've got your anion and your cation, which is anion is a negative charge and a cation is a positive charge. And that, I mean, it really, I was trying to make it way more
harder.
complicated than it was.
Yeah. So now you have your water and pH. So in pure water, some of the water molecules naturally ions are ionized into hydrogen ions, and some are hydroxide ions. So the pH scale measures these said ions. So your hydrogen ion is acidic. Your hydroxide ion is alkaline. So only aqueous solutions have a pH. So your non-aqueous solutions, such as your oil, your alcohol, they do not have a pH. So without water, there is no pH. So
yes,
just remember that one.
So if you were to measure pH, which you can do you can buy those little strips like they use to measure pH in a pool. If I put my pH strip into my perfume bottle, it's not going to show me a pH because that's alcohol based.
Yes.
If I put it into my shampoo bottle, which has water, I'm going to be able to find out what the pH of it is.
So your pH scale, we said that's your potential hydrogen. The scale goes from?
It goes from 0 to 14. I feel like Vanna White.
I wanted to say 0 to 40. I don't know why. I don't know why.
All right, so it's a 0 to 14. 7, right in the middle, is considered neutral. Distilled water has a pH of 7, meaning it is pure water. So it is considered neutral. It is a pH of 7. If you look, our hair and our skin, our bodies are actually acid. So we are right in here. We're about 4.5 to 5.5, so right around that 5 mark, depending, it varies from person to person a little bit. But our hair and skin is considered acid. Vinegar, lemon juice, beer, all those things are acid. Baking soda, ammonia, those are alkaline. And Ms. Baker said earlier, alkaline hair products soften and swell hair. And if I swell some hair up, that cuticle, that outside layer is going to open right up. So a lot of times we will use hair products, chemical hair products, that are alkaline. And then we use what's called a neutralizing liquid or shampoo. But neutralizing just means it's going to bring the pH down to more of the acid side or to more of the neutral side. So if I'm using something here, I may need to use something here to neutralize it so I can get it back to here. But when we're doing hair products, we want to keep everything right around that 5 mark.
And that's why it's important, like when you're reading the directions of a certain product, especially a chemical type product, if is it going to bring that hair up? Do I need to bring that hair back down? So you may have a two-part step in certain chemical products that you use. So.
Right. So if I think about it, okay, if my natural hair's pH is a 5, and I wet my hair, let's just say the water coming out of the tap is pure. We all know that's not true, but let's just pretend it is. I wet my hair. What have I done? I have just raised the pH of my hair. It's probably not the 7, but it's higher than it was. It's probably like around a 6, 6.5. Because I added water, which is more alkaline than my hair naturally is. So that softened and swelled my hair. That's why my hair is more fragile when it's wet than when it is dry. Lemon juice and vinegar are way acid, and I'm sure some of you have heard your parents or grandparents or somebody you know say, put vinegar on your hair, it makes it shiny. Put beer on your hair, it makes it really soft and shiny. Well, what that acid does is it takes that hair and it shrinks it and flattens it down, which does close that cuticle up and make it reflect more light, which makes it shinier. So it's not a wives' tale, but who wants to walk around smelling like vinegar or beer? Nobody. So we actually have professional hair products that have more of an acid pH in them for that purpose. Okay. I can talk about pH forever.
Yes, you can, girl. That is fine. So, okay, you have your acids and your alkalis. All acids owe their chemical reactivity to the hydrogen ion. So, acids have a pH below 7. Your alpha hydroxy acids, your AHAs, this is something that you would sometimes put on your face. It exfoliates the skin.
Of skincare products.
It helps adjust the pH of a lotion, a conditioner, or a cream. Then you have your thioglycolic acid. This is used in some permanent waving solutions to contract and close the hair cuticle. So you will have what is called a thioperm or a thio relaxer, and that is, it's a acidic based permanent wave solution or hair relaxing solution. So then you have your glycolic acids. Do you want to add anything onto any of that? I could tell you were.
Well, I was thinking about it, but when we think about our thio products, our permanent waves and relaxers that actually are acid, you can have a pH of 6 and be acid, but not as but it's still more alkaline than your hair at a 5. So it's kind of in between where your hair is at a 5 and that 7. So that's in that pH range where those products work. Okay.
Alkalis. This is your base. They owe their chemical relativity to the hydroxide ion. Okay, alkalis have a pH above 7. They feel slippery or soapy on the skin. Sodium hydroxide, also known as a lye, it's used in chemical hair relaxers. I believe one of your videos this week talked about sodium hydroxide in the hair and what it actually does. If you've ever watched Chris Rock's Good Hair,
yeah.
He talks to a guy who is a chemist, and he shows what pure sodium hydroxide will do to a Pepsi can. So
it's also in things like drain cleaners.
Yes. Callus
softeners, hair removers like Nair, things like that usually contain sodium hydroxide. Okay. All right, so when we get to these acid-alkali neutralization reactions, what I talked about before is you have these reactions, and neutralizing shampoos and neutralizing lotions are generally used in conjunction with some type of alkaline product. So I'm not going to get too detailed into this, But if I put a product on my hair that has a really alkali pH of 9, okay, like a permanent wave is a good example, has about a pH of a 9, then I have softened and swelled my hair, I've chemically altered it, so I can't leave it like that. I can't take I can't put that solution on and take those perm rods out and leave my hair at a pH of 9. If I do that, it's going to be so fragile and weak, those curls are going to fall out, my hair's going to break, it's going to be bad. So that's why we have what we call neutralizers. Sometimes we have neutralizing liquids that we use with perms, neutralizing shampoos that we use with relaxers. And what those neutralizing products do is they bring the pH back to acid. So if I'm trying to get my hair at a 9, or my hair is at a 9, and I'm trying to get it back to a 5, I'm going to use something that's way acid, probably like a 3 or a 4, to help counteract that 9 and bring me back to around that 5. I also want to point out that when we talk about pH balance products, you'll see a lot of pH balance shampoos, pH balance body wash. That just means it is balanced to the pH of hair and skin. So it's right about that pH of 5. So when you use it, it doesn't alter your pH. All right, so that is everything for that chapter. It's not that complicated when you start studying ingredients and how they work based with the chemistry of the hair, and we talk about how acids and alkalis affect the side bonds of the hair. If you remember that salt bond, what do you need to change or break a salt bond? A change in pH. So that's why a lot of our chemistry comes into play in our profession. So we need to know what chemistry is, the difference between organic and organic chemistry.
We need to know what matter is. We need to know the properties and exists as a solid, a liquid, a gas. We need to know the benefits for the clients so that way they can take advantage of salon services. That way when you talk to a person about a certain product, you can say whether it's going to be good or not for their hair.
Yeah,
So
there are products out there in the world that have like a lot of protein products that mane and tail. Okay, that was not even made for people. That was made for horses. Their pH is different than ours, and the ingredients they need are different from ours. And if we use that product on our hair, it's going to be great for a couple of times, and then our hair is going to start getting dull and lifeless and start breaking off because the pH is wrong and there's waxy buildup on our hair now. So we need to make sure we know our ingredients.
baby shampoo is another one.
Yes.
It's not formulated for adult necessary hair.
It is formulated so if it gets in your eyeball, it does not make you cry. Your eyeball has a totally different pH, more of a 7 than your hair does. So if you use it in your hair, you're making it more alkaline and your hair is going to break. All right. So you need to know what you're talking about as a professional.
Yes.
You need to know these ingredients, understand how they work, understand the pH scale, and how they interact with the chemistry of the hair, all of the bonds inside the hair. So have fun studying. I expect to see lots of good grades on this test.
Remember, you got 2 chances to take it. So,
Right? I think, no, just one.
no, just one chance
Just one,
to take
but
the
you
test.
get a practice one.
But you got your practice test. So,
Yep. So do your flashcards and your study guide.
yes, get those hours in.